The formula for the entropy change in a process is change in entropy is equal to heat divided by temperature. It turns out that entropy, which is symbolized by the letter S, and therefore delta S is the change in entropy, was originally defined to be a conserved quantity for reversible thermodynamic processes. And that's the reason why in the key concepts slide, the version of this formula there has the reversible subscript on heat. It may not be desirable to always write that out as such a long word in a mathematical expression. So you can either just leave it unsaid and just remember this needs to be a heat corresponding to a reversible process, or if you wanted to, you could put a little R subscript in it like that. And there's some subtlety in that because if you want to calculate the entropy change for a very particular process that maybe is described in a way that is not reversible, then what you need to do is come up with an equivalent reversible process that has the same starting point and end point, and then calculate the entropy change based on the heat involved for that process and the temperature involved for that process. In this class, my intention is not really to get into too much depth into entropy calculations because many of them involve the use of calculus, particularly if the temperature changes. So we're going to kind of confine our attention to questions where the temperature can be argued to be a specific constant value so that this formula can be relatively easily evaluated.